All right, what's up everyone? Welcome back to Robbie's Office Hours, your one-stop shop for everything math. So in this video, we're talking about U-substitution with bounds. So we're gonna do evaluation of definite integrals, but we're using U-substitution, okay? Now this can get a little complicated and there are some really subtle details that a lot of people typically do, which are kind of wrong, but I'll point those out as we go through this. So I want to be as precise as I can with these ones. So let's jump in. So in this one, I'm given the integral from e to e cubed of 1 over x, natural log of x, the whole thing for natural log squared. So again, as with anything u substitution, you want to ask yourself the question, what can I set u equal to such that the differential du is occurring someplace else in here, all right? So you kind of stand back for a second and you're like, well, I could set u equal to 1 over x, that's not really going to help me. I could set u equal to x, that's literally going to do nothing. And if I set u equal to natural log, that might work, okay? So if I set u equal to the natural log of x, then du is equal to 1 over x dx. So that suggests to me that dx is equal to, solve for dx, I just move over, that's x du. Okay, so that's fine. But now here is the trick, and this is the number one mistake that people make, and it's kind of a small one, it's not really a big deal, but it does matter, okay, and it is important. So this is equal to, these bounds on this side from e to e cubed are in terms of what variable? They are in terms of the variable x. So really, if you want to be very precise, you could say this is like x equals e up to x equals e cubed. If I'm going to write an integral over here, which is a definite integral, and they're going to be in terms of u's, then these bounds had better be in terms of u, okay? So first off, let's forget about the bounds, okay? And let's go in and plug in for the integrand and see what we get. So I'm gonna have 1 over x times dx. Well, what do I see? 1 over x times dx is just du, and natural log is just u. So this just becomes du over u squared. Okay, that's equal to that. But it does not make sense, and it is incorrect to just carry these bounds over and say this is e and that's e cubed, because these are now in terms of u. All right, so how do you do that? Well, look, when x equals e, you use this formula right here to find out what u is. Okay, so if x equals e, then u is the natural log of e, which is 1. Okay, so that's going to be what replaces this. This will be my u equals 1 down here. That's my lower bound. If u equals e cubed, if x equals e cubed, okay, then u is equal to the natural log of e cubed, which is just 3. So that's going to be my upper limit. U is equal to 3. Okay? Now you may say, well, Robbie, I don't want to change my bounds. I just want to evaluate and then back substitute in for u and then plug in x. That's fantastic. My voice just cracked. That was beautiful. And then plug in for x. That's completely fine, okay? That's completely fine. But if you want to change your bounds, this is how you do it, okay? So now we can say, well, this is the integral from 1 to 3 u to the minus 2 du. Okay, so that's equal to what? Add 1, so that's negative 1, divide by, so that's minus 1 over u, evaluated from 1 to 3. Plug in the 3, be mindful of your negatives, so this is minus 1 over 3 minus 1 over 1, so that's a plus, so this is 1 minus a third, which is 2/3. Okay, so that's equal to 2/3, and that's how you change your bounds, all right? Let's go down to this one and see what we have. Again, you stand back and you say, like, okay, what could I do? If u is equal to e to the 1 over x, then du is going to involve e to the 1 over x, and I don't see another one occurring, so that's not going to work. If u is x squared, then du is 2x, and I don't see any 2x's running around. But if I set u equal to 1 over x, then du is equal to minus 1 over x squared dx, which tells me what? It tells me if I want to rewrite this, I could rewrite this in the following way. I could say, well, this will be the integral of what? If I cover that up, 1 over x squared dx, that's dx over x squared. That's this term here. Okay, so I have a negative there. So really, this term right here if I were to multiply it by negative, would give me du. So I'm going to bring that negative out front. Okay? Then I'm going to have my 4 e to the 1 over x. 1 over x is called u, du. All right? Now what happens with my bounds? Now again, these are the bounds for x. So if I set x equal to 1 and x equal to 5, then I could do the same thing I did over here. If x equals 1, then u is equal to what? Well, I just substitute in for my formula, okay? So if x is 1, I get 1 over 1, that's 1. So that's going to be my lower bound there. If x is equal to 5, then u is equal to 1 over 5, because that's what my formula is for u, okay? So this will be 1/5. All right, so I bring the 4 out, join it with the negative, so I get minus 4. The antiderivative of e to the u is just e to the u. That's a nice one. E to the u, evaluated from 1 up to 1 over 5. And so what do I get? Again, be mindful of the negative. Minus 4 e to the 1/5 minus minus 4 e to the 1. So those will add, and I'm left with 4e minus 4e to the 1/5, okay? Whatever that beautiful number is equal to, all right? So there you have it. You've got 2 examples using U-substitution and changing the bounds into u rather than back substituting and using the original bounds in x. If you have other questions you want me to work out, put those down in the comments down below, and like, subscribe, do all the normal things, and we'll keep this thing going.